In this video, we'll be looking at the present worth method of the engineering economy. Looking at this question, for the following machines whose cash flows are given in the following table, which of them would you recommend to an investor who wants to go into a business that requires one of the machines? So this is a table. Machine A has an initial cost. This is the one for machine B, and then this one for machine C. Now, this present worth method simply means you will convert all cash flow to its present worth and then compare the alternatives to know the best one for the project. So we'll be converting all this cash flow to their present worth. So the first one you see here now is the initial cost. Initial cost will not require a conversion because it is a present amount. That is what it will cost you to start the project. So initial cost, present sum, thus no conversion. Now we start analyzing other cash flows in the question. Now what next you see? Now for machine A, the annual service is given. An annual service is money you'll be using to service this machine annually. So you have to take it to the present sum. And if you remember, we have 6 interest factors. And the one that they have this relationship is your equal payment series present work factor, where you can take annual payment to present sum. Converting the annual service, we use this factor which the formula is A into 1 plus I raised to power n minus 1 over I into 1 plus I raised to power n. Substituting our values, now we have 25, 3, 5, 8 point. This is the annual. This is the present worth when the annual service has been converted to its present work factor. So you are going to do this for machine B and machine C. For machine B, your present work will now be 6,000. And this will give you, you are using dollars. For machine C, we're also going to do the same. Remember what we are doing? We are converting the annual service worth to its present sum. So now you're done converting the annual service, we are going to convert the salvage values for each of the machines to their present form. I know salvage value is the money you get at the end of the service life, so it is a future amount. In converting the salvage value, we are going to use the relationship that takes future money to their present worth, and that is the single payment present work factor, which is this is the factor P over F I N, and the formula is 1 plus I raised to power minus n. For machine A, the present worth of the salvage value is equals to 1,000 into 1 plus the interest raised to power negative of the service life. and this is equals to if you have watched to this point and you've gotten a value, please help us subscribe to the channel so that we can do more videos on this. Thank you. So let's proceed. For machine B, the present worth of the salvage value is what's the salvage value for machine B? Salvage value for machine B is 1,500. So you have 1,500 plus 0.1. Now this gives us so for machine C, we are going to have 1,200 and this gives us now that we are done converting all the cash flow to their present worth, we are going to sum all of them for each machine to determine which machine is recommendable. So starting with machine A, now in summing your cash flow, your income is positive, here your disbursement is negative. So the only income for machine A is the worth of the salvage value, which is now minus the initial cost, which is 10,000, minus the worth of the annual service. Where is machine A? The annual service is 25. I think that's all. And this is our value. We are going to do the same for machine B and machine C. You will see that machine C has the least negative present worth value. So machine C is recommended. Remember, this study method is used for basis for comparison. You want to know which machine is used. If you have watched to this end, I know you have not subscribed, please go back, subscribe to this channel, like, comment and share this video. See you in our next class.